Hi everyone, my name is Alicia Ball, and today I'm going to be solving problem 4.12 for the fall 2020 CM 4610 class. And that problem reads, when manometer M is polymerized at 50 degrees C using 0.02 moles per liter of initiator and 2.0 moles per liter of manometer, the molecular weight formed initially is 100,000 grams per mole. That same molecular weight is produced at 63 degrees C with the same amount initiator, but with a manometer concentration of 4.55 moles per liter. What concentration of initiator should be used at 70 degrees C to get a molecular weight of 150,000 grams per mole if the manometer concentration is 6.0 moles per liter? So we're going to begin by writing out our given information. In this problem statement, we were given three different cases, each one giving us a temperature, a concentration of the manometer and initiator, as well as the molecular weight for the manometer that was formed. And so what we're trying to find is the concentration of the initiator that needs to be used to given the certain parameters in case 3 to achieve that 150,000 grams per mole for the molecular weight at 70 degrees C with a manometer concentration of 6.00 moles per liter. So we're just going to start by writing out all of our information into an easy to read table so we can refer back to it while solving the problem. Now that we got that all solved and figured out, we're going to start by writing out the variables that we're going to be using for our problem. So first we have the molecular weight, which is going to be denoted by m sub n. Then we have the concentration of I, which is just going to be used by or denoted by a regular form of how you would with the concentration with the brackets. And finally, we are going to have V sub n, which is going to be related to our chain length of our manometer. After we have our variables, we're going to define the relationships. We're going to be starting off with equation 4.15 or 4.15 from the book, and it is given as V sub n, which is our chain length, is equal to K sub P divided by 2, multiplied by K sub I minus K sub T raised to the negative 0.5 times the concentration of the manometer times the concentration of the initiator raised to the negative 0.5. Again, it's equation 4.15 in the book. And then we're also going to use some other relationships so we can manipulate this equation so it will be much more user-friendly to us. For starters, we're going to use V sub n is equal to m sub n, which means that the chain length is proportional to our molecular weight. This was actually given in the problem of interest file on Canvas. So our next relationship is just relating the chain length to the initiator concentration. This relationship was found on page 112 of the book, where it references that the molecular weight is equal to x sub n, which we already know that the chain length is proportional to the molecular weight, so I just filled it in, as you can see right there. Next, we're going to fill in our variables for just our given quantities that were given in the initial problem statement. So we have a molecular weight of 100,000 grams per mole, initiator concentration of 0.02 moles per liter. And then we are just going to find K using that given relationship. M sub n is equal to K divided by the concentration of the initiator raised to the half. And so I just rearranged the equation so we can solve for K, get with our given values. And so by plugging in 100,000 and then that's 0.02, we end up with a K value of 14,142.14 roughly. So next we're going to use K to solve for our final initiator concentration using that same relationship. So we're going to rearrange it this time, so we're solving for the concentration of the initiator, as you can see right there, and we're going to set that equal to K divided by 150,000 for our molecular weight this time because we're trying to find the initiator for trial 3 instead of the other ones that used 100,000 grams per mole for their molecular weight in the past. So plugging everything in, we end up with a final initiator concentration value of 0.00889 moles per liter. And I just highlight that real quick. And yeah, that is how we solve our problem. Thank you.